Good morning, everyone, or good evening, depending on where you're listening from. Thank you for joining us today. It's great to see so many regular faces to EuroSTAR webinar attendees, I should say, as well as lots of new faces. We're looking forward to a great talk with Adam Leon Smith. This is our third and final talk in this Test and Quality webinar series, and we're delighted to have you with us today. All talks will be available to watch back on demand on EuroSTARHuddle.com. It is free to join, and as a member, you have unlimited access to all the ebooks and webinars from the testing experts, as well as thousands of blogs from the community. Thank you to iSQI, our partners of the Test and Quality Summit in Dublin, for supporting these webinars. Adam will answer questions at the end of the session, but feel free to ask questions throughout. And please feel free to join in the chat. To ask questions, just toggle the chat mode to Q&A. So without further ado, I'd like to introduce today's speaker, Adam Leon Smith. Adam Leon Smith has 2 decades of experience in technology and has held senior roles at Barclays and Deutsche Bank, delivering large, complex transformation projects. He is now CTO of Dragonfly, an international consultancy focused on software testing and quality assurance, with particular focus on AI. Adam is the current chair of British Computer Society's Special Interest Group in Software Testing and is also ISO IEC convener and editor, and is involved in development of numerous international standards relating to AI and quality. He is a member of the European Commission's AI Alliance and in the IEE's group developing international standards on technology ethics. Hello, Adam. Welcome. We're delighted to have you with us today.
Thank you. Thank you very much for the introduction. So really looking forward to talking about this topic today. AI and quality is an area I've been focused on for about 4 years now. And it is a really fascinating area. It's one of the most disruptive changes, I think, to how we think about testing and quality that I've ever seen in my time in testing and quality. It presents a fascinating set of challenges and opportunities, and I'm looking forward to telling you a bit about those today. I'll also talk a little bit about the quality challenges with AI. I tried to make my list of top 10, but I've actually got a list of 11, unfortunately, so you'll have to let me off on that one. I'll also talk about some of the tools and techniques that you can use to test AI, and also some of the tools that you can use in testing that use AI that actually enable your testing. So while we're going through this, I've also got a poll running. So before we get to the Q&A stage, I'd appreciate it if you can have a vote on the poll. And the question is, do you expect to test an AI-based system in the next 12 months? So first of all, just a little bit about AI. What is it? It's a big buzzword. I think we're all getting more and more familiar with the topic over the last few years. And it's really become something that every business is looking to implement in some way. It's risen and become more popular, not just because of technical inventions and technical developments, but also because there's so much more data around these days. Data is really what runs AI, not code. And I want to get that point across today. The amount of data that's available about people and things in the world has increased exponentially over the past decade as the world's become more internet enabled, more technology enabled. And a lot of that data is about us as people, but it's also about more boring things, particularly in the business side of AI. It's used in your phone. Every time you open your phone, there is applications running that are using machine learning. When you're doing something as simple as reading the news or doing a Google search, there's machine learning in the background there. It really is anything that applies knowledge to make decisions, predictions, recommendations, as opposed to using explicitly specified logic. So if you think about old style computer programming, where you literally specify the inputs, some logic, and then you get some outputs, the contrast to that is AI systems use knowledge for reasoning. There's lots and lots of challenges with verifying the behavior of AI through traditional testing techniques. And there's also, as I said, benefits to the use of AI in testing. So I'll talk about both of these topics today. One really big challenge the industry has, and you'll read a lot about this in the press, and particularly if you follow regulatory developments, especially in Europe, is everybody needs to be convinced that AI systems can be trusted with important decisions. And societal concerns about technology are a lot more relevant with AI, both because of the way that it works, but also the potential implications of how it can be used, the use cases. So let me first talk a little bit more about trustworthiness. So this is a word you'll hear a lot coming from regulators. The EU in particular talks a lot about trustworthy AI. And the EU specifies trustworthy AI as something that is lawful. So it abides by the laws and regulations in the area it's used. And that may be data protection law, that might be human rights law, might be health regulations. Trustworthy AI is also ethical, so it respects ethical principles and values. And that's an interesting one, I think, drawing a contrast between ethical and lawful here. One really good example of how algorithms can get quite complicated in different regions is the insurance example, where insurance is priced based on things like life expectancy, which correlate with things like gender. And in some countries, it's legal to price insurance differently and offer it to different people based on their gender. In some countries, that isn't legal, particularly in the EU. And it's a court ruling that I'll tweet after this. In fact, as I go through, I'm going to mention various references, and I've got some URLs embedded in the slides, but obviously you can't click on them because it's a webinar. So on Twitter afterwards, I'll send out a list of some of the references I've mentioned. The other thing the EU says is that AI needs to be robust from a technical and social perspective. And from a technical perspective, that really means it has to produce reliable outputs given really any possible inputs. And that is a whole challenge in itself for reasons I'll come on to. Now, that's the EU view. Within the standards community, there's also an emerging view that trustworthiness is the system's ability to meet the expectations of stakeholders in a verifiable way. In contrast to the definition in the standards community of quality, which you can disagree with as much as you want, where quality is conformance to specified requirements. So my point there is not that these definitions are right, any of them. My point is that quality is what all the regulators are talking about when they talk about AI. They're looking at it in different angles and they're looking at it from a different way to how we've looked at it before, but quality is absolutely crucial. My view is that system owners need to make trustworthy AI by specifying detailed, verifiable requirements, including considering all the different legal, ethical, and social issues. And engineers, whether we're developers, whether we're testers, can help make systems trustworthy by delivering and verifying those requirements. That means that stakeholders can then trust a system because it's objectively and verifiably trustworthy. So now let me talk a little bit more about the difference between traditional software and machine learning, because this is key to a lot of the problems that we see. In traditional software, we write code, that is, we specify logic, and that code processes input data, it executes and produces output data. And this is what we're used to verifying, this kind of flow. With most machine learning systems, and there's many variations on this flow, and there's also other types of AI that are not machine learning, what we're actually specifying is model parameters, and then a model processes input data. That produces an output model, which is then combined with traditional code and logic and input data in order to produce output data. This model training part of the process can be called automation without specification. We're experimenting with data and trying to find the best algorithms to identify patterns in the data to produce outcomes, whether those are decisions, predictions, classifications, or numbers. So this is an important point to understand because this creates a lot of the problems that we see in the quality and machine learning space. So as I said, machine learning is the most common AI method, and it's difficult to specify quality, and it's difficult to analyze how to test those aspects of the system. But I'm not just saying that as a quality specialist. there was a great survey done in Japan with 278 machine learning engineers, and they were asked what the biggest new challenges they were facing when they were integrating machine learning into their systems. And the two biggest problems they identified were decision-making with customers and testing and quality assurance. And they identified the lack of an oracle and imperfection as the top causes of this. So what do we mean by that? Well, an oracle in testing is the knowledge or thing that allows us to determine whether a test has passed or failed. And that's directly related to our ability to specify what we want from a system, which is directly related to the concept of taking data and experimenting with it to try and find the best way to find patterns and make outcomes happen in an accurate way. Imperfection is also an important concept here, because by using correlation, we cannot get to 100% accuracy in most cases. So most systems that use machine learning don't have 100% accuracy. They have false positives, they have false negatives, they have variability in the results. So you can't think about passing and failing in the same way that you can currently usually. So again, I'll tweet out a link to the paper that I'm referring to, which is at the bottom of the page. It makes really good reading. So now onto my top 11 quality problems with AI. The first one is, if there's less specification required to produce software, how will we define our tests? And this is exactly what I was referring to on the previous slide. If we don't know how the automation is effectively being achieved, because it's inside a black box model where we can't explain every result 100%, how are we going to define the tests? How are we going to investigate the failures? This is probably at the root of a lot of the problems that people experience in testing machine learning, but it's not the only problem. In some scenarios, we're writing AI systems to do things that humans can't do. They can't calculate. They don't know the answer. How about if we're writing an AI system to search for extraterrestrials? How are we going to know, given a set of planets, a set of solar systems, whether it has been accurate in determining that extraterrestrial life might exist? There's ways around this, but you can never be 100% sure. Another quality problem is test coverage. We're used to talking about test coverage in terms of lines, statements, conditions. When we're using things like neural networks, which are replicating the way that neurons fire in the brain, we have to use completely different techniques. We have to look at exactly which neurons have been covered by tests. This is an emerging research topic. There is certainly ways of starting to do this with some algorithms and some ways of using AI, but it's a really big field that we're really just scratching the surface of at the moment. And I think it's linked to, how do we know what to test? It's how do we know when we're done testing? So the fourth problem is, if my system's self-optimizing, how are my tests going to change this? And I've seen this happen where the same model is used in testing and production. You might be familiar with the concept of the pesticide paradox. The more we run tests, the less value they have, because we find a lot more and more defects. The code gets better and better. And whilst that's a good thing, the tests themselves decrease in value. If we do that with some kind of model that's learning, the model might become skewed towards what I'm testing. So it might start to respond better to things that have been asked in testing, and that has an adverse effect on things that weren't asked in testing. So you may find that you have a green list of tests, but actually running those tests has meant that things that might happen in the production environment actually work less well. Another quality problem that we have is, if this system that we're testing is intended to mimic human capabilities, how do we define human capabilities? So you might be familiar with the Turing Test, which is a blind or double-blind test of whether a human can tell the difference between an AI system or a human. Things haven't really improved significantly since the 1950s. That's still our best way, really, of determining whether a system mimics human capabilities. And again, unless we can specify exactly what we mean by that, it becomes very difficult to prove. It becomes very subjective. So my sixth problem is something called the no free lunch theorem. Any general purpose algorithm is equivalent when its efficiency and accuracy are assessed across all possible problems. So an algorithm may perform very well with data that you have for testing, but when you expose it to different data in the real world, you may see a significant change in quality. This is a mathematical concept, and I'll tweet out a link to a really good Wikipedia article on it. But it essentially relates to the difficulty for an AI system to generalize. And this really is a kind of an unsolved problem. The way that we think of AI these days is narrow AI designed to solve a very, very specific problem. What people talk about in sci-fi and in research is general purpose AI that's able to deal with lots of different problems. Quality problem 7. So bias is a very broad topic that includes things like cognitive biases, human bias, societal bias, data bias, and the related statistical biases. But looking just at the data, all models are biased based on the data used to train them. And that may be good, it may be bad. But the data in the training environment and the test environment is absolutely crucial to assessing the amount of bias that exists in the model and how that affects the outcomes. There's lots of high-profile examples of bias in an ethical sense, whether it is in the prison system, in the US, in the UK, and university applications, and lots of examples of how this can be tied to inappropriate personal characteristics like gender and race. But bias is ultimately a quality problem that's wider than ethics. It is essentially a narrowing of the functioning of an AI system so that it favors one thing or another. So the next problem we have is that we train machine learning models based on correlations between various different inputs and how that correlates to the desired target characteristic, the output, if you like. And those characteristics do change over time. If you think about an AI system that was built to predict how many people go to different shops and different sales of different things in shops, that will have changed dramatically recently as everyone's been in lockdown. So unless people have taken their models and retrained them based on recent data, those systems will be inaccurate. What this means is that you have to constantly continue testing systems after they are put in production. The production operation of a complex AI system is very different to that of a traditional system in that it needs to comprise testing processes, data science processes, and various workflows to constantly review and audit the outcomes of the system. Another problem is when determining whether a system is ethical or fair. In the example of insurance I gave earlier, sometimes there are trade-offs that have to be made between accuracy and fairness. Things can be highly accurate but unfair. Things can be fair but inaccurate. This is a whole other topic in itself in terms of how do we integrate ethics into technology workflows. Another problem we have with AI is something called automation bias or complacency bias. So this is where we start to trust a system almost more than our own judgment. So a really good example of this is self-driving cars. And there was the example of the self-driving car that hit a pedestrian because the driver was looking at their phone. And this is a good example of this because the driver had begun to trust the system to drive the car so much that they stopped following the recommendation. They should always keep their eyes on the road and be ready to respond if the system makes an error. This can have real life impacts. I've seen this actually impact testing and UAT phases where users start to be able to process things quicker, to do more because they've got AI systems supporting them, but they don't really think as much about the accuracy of the results. And while systems may get faster, systems may be able to achieve results more efficiently, we need to think about the end-to-end quality process, including any human in the loop. Another problem we have, and I talked about robustness at the start, what if a system can be tricked? If you take a simple image processing algorithm that categorizes cats versus dogs, there are ways to change just 1-2 pixels in those images, and the system will think it's a cat instead of a dog, or vice versa. Lots of machine learning systems rely on inputs from open source data, like news articles, social media, to do things as even in financial services, things like price forecasting. Well, those things can be manipulated. So the risk of AI systems being tricked is very real at a technical level. So they're my top 11 quality problems. But what do we need to really think about in terms of quality of systems that use machine learning or other AI techniques? So I'm a big fan of the Square series, ISO 2510, which talks about product quality. It talks about how to specify and evaluate quality requirements in systems. And this diagram, which is on their website, which breaks down all the different characteristics of quality. Things like, on the far left, it's functional completeness, correctness, and appropriateness, all the way through to the far right, how easy is it to install and replace. Now, there's a whole range of different things that change when we think about the quality of AI systems. How easy is it for the AI system to learn? And is that something that's done on a continuous basis? How robust is it? How able is it to operate based on any input data? How can we trust it? Can we control it? Particularly if you think about something like a robot that assists with social care. And to what degree should users be able to control that? Can we explain it? Can we explain why it did a thing? And that is a real problem that people struggle with in understanding test results and defect reports right now. Correctness. So correctness is no longer a simple pass, fail, yes, no. You have to think about it as what's called a confusion matrix in many classification scenarios. So how many true positives, how many false positives, true negatives, false negatives. It's a more complex measurement. How complete is the system for unseen situations? How free is it from bias, whether that's ethical bias or data bias or statistical bias? Privacy. So I said at the start, there's a lot more data flying around about us these days. Does the system breach any privacy principles? For instance, under the GDPR, if people are making, if systems are making material decisions about people that might affect their rights, they need to consent to that. And then, of course, ethics, probably the hardest one to specify in measurable principles and tests. So what about testing these quality aspects? So here's a few of the important techniques that are used for the testing of AI systems. So one of the interesting ones is metamorphic testing. So this is a kind of testing that's almost based a little bit on common sense, but also on prior test results. So it's the only testing technique that requires 2 iterations before you have a result. And that's because each test is based on the output of a previous test. This can be explained in one simple way. If you think about a search functionality on say a house rental website, if you search for properties in an area, you maybe get 100 results. But if you want to search for properties in an area with, say, air conditioning, I say that because it's quite hot here today, then maybe you apply a filter. So common sense tells you that there's a relationship between applying 2 filters and the number of results. You should probably get less results when you put a filter on for air conditioning. So this can be explained a lot more mathematically and in a lot more detail, but that's a high-level explanation. Robustness testing. So I talked about changing a few pixels in an image to change the results of a system's processing. So that requires quite a lot of both maths and automation to do. but it's possible to use tools to generate test data that's designed to confuse systems. Expert panels. What if we're testing something that really is designed to replace expert judgment? So let's say medical diagnoses from doctors. You might want to establish a panel of users that will decide whether results are correct or not, essentially to be your test oracle. And that comes with a whole range of problems, because you need to think about whether that's blind, double blind. You need to think about whether there's bias in their results. You need to think about the way that humans provide results, like I think so, or maybe I'm not sure. Those aren't things that will normally come out of an AI system in the same way. So you need to be able to interpret those human results and map them across to system results. External validity testing is a really important technique. That's all about getting data that isn't in your input data and using it to validate the quality of a system. So if you're using a system to predict something, maybe you'll look at separate data about whether that thing really occurred. Maybe if you're using a system to predict someone's age, you'll gather data about their actual ages outside of the system so that you can determine whether the test passed or failed. A/B testing, an approach used in marketing a lot and e-commerce, is also relevant to AI systems, and we can use that to do things like field trials and determine the quality of a system as well. So there's a range of topics here that people need to learn about. And these are all covered, this and more is all covered in the A4Q AI and software testing certification that's available through iSQI. So there's a whole lot of background to AI that I won't be able to cover in this short session. There's different types of AI, symbolic versus sub-symbolic AI. There's lots of types and techniques that are actually not machine learning. You really need to learn about the key algorithms, not in terms of being able to implement those algorithms, but in the same way that a web app is different to an installed app, and there are different potential quality problems that you might need to look for in certain ways in testing. Different algorithms have different properties and knowing what they are can help you plan your testing. Understanding the limitations of AI is really crucial to taking a critical thinking approach to how we test it. All of the different quality problems that I've talked about and more are important to understand to help scope your testing. How to use AI tools in testing and how to critically assess the claims of product vendors. How to specify acceptance criteria in a non-binary, non-pass-fail world. The different types of testing that I've talked about, but also how they integrate with model training and testing that's usually conducted by data scientists. Metrics is obviously very important. I talked a little bit about confusion matrices. And all these things are really needed to understand how to apply test levels, test phases to an AI system. So again, I'll send a link to some upcoming instances of this course that are coming up if anyone's interested. So I talked about standards a few times. So the reason I got interested in standards in this area is because to learn what I learned about how to test AI systems required many, many months of reading lots of academic papers, which is really hard, trying to parse information from research and compile it into what do I need to know and do as a tester. So the way that traditionally research and best practices become more available is through standards. So that's why I've kind of got involved in the international standards community. There's a report coming out on how to test AI-based systems this year, I think. There's work starting on defining a new version of the quality model that I went through for AI-based systems. There's reports coming out on bias, trustworthiness, robustness, risk management, and ethics and societal concerns. If your organization uses international standards, keep an eye out for these pretty useful, pretty high-value deliverables coming out over the next couple of years. So now to talk about AI-enabled testing. So this is a whole different topic, although some of the problems also apply. So the first interesting area is test data generation and synthesization. So I'll show you an example on the next slide. In fact, I'll go forward and show you now. So this person does not exist. And you can go to this URL, thispersondoesnotexist.com, and you can sit there all day pressing F5. And this is using something called generative adversarial networks to generate faces of people that aren't real. And it's fascinating how detailed the apparent photographs are. So, for instance, if you're testing a system that uses facial recognition, you could use this website to generate a whole range of test data rather than testers using photos of themselves. Another area is defect triaging and analysis, finding duplicate bug reports, looking at the best person to fix a bug. They're quite interesting topics that are applied to the management of technology. Detecting anomalies is another one. I'm sure you can imagine how detecting anomalies, traditionally used in fraud detection, can be applied to analyzing test results, whether it's screenshots taken during a test automation process or large data sets that would normally take testers a long time to go through. In regression testing, choosing which test to run first is a really good use case based on things that have happened in prior test cycles. As testers, we kind of, once we've been working on an application for a few releases, we get a feel for the risky areas. We're able to sort of think about what the developers have changed and figure out what might break. That can be done using machine learning as well. Estimating effort, probably not very accurately at the moment, but that can be done as well based on analyzing written requirements, JIRA tickets, and things like that. Very, very commonly, and I'll put some examples up on the screen in a minute, in the test automation space, recognizing objects in a UI. So an object might be a button you click or a link you press or a radio button or something like that. One of the biggest problems in test automation maintenance is how those objects change. So that also can use machine learning in multiple different ways, actually. Identification of visual bugs is another one. So visual testing is something that there's a lot of focus on at the moment. Being able to generate, for instance, lots of versions of a web application running across lots of different browsers in lots of different scenarios and be able to use image processing algorithms to identify visual bugs. So there's a lot of players in this market. Tools in the test generation space include tools like Eggplant, Functionize, and Test Sigma. There's a tool called Neuro from Dragonfly, which does test and defect management. In the functional test automation space, there's another set of tools, including Retest, TestIM, AppVance, and again, Functionize. In test data synthesization, there's a company called Primal that recently helped me generate geolocation data working on a COVID contact tracing project. In the visual test automation space, Applitools, Source Labs, Eggplant, and Percy are the four main offerings. And in test selection and optimization, as well as Neuro, there is the Signity tool. So there's lots of different companies out there offering AI tools that help you with your testing and your quality challenges. Obviously, you have to assess these tools based on some of the quality problems that I've outlined. Imperfection exists, and you need to think about those risks when you're applying AI-enabled tools into your testing process. Okay, great. So now we're on to the questions. So before I answer any questions, I see we have about half and half in terms of the poll. So 51% of you expect to test an AI-based system in the next 12 months. For the 48%, hang on, those numbers don't add up to 100. Okay, for the 48% that said no, you may find that you are. It's always worth keeping an eye on what your product teams are doing. Lots of teams are thinking about incorporating little bits of ML inside a wider, more complex system. Okay. So let's move to Q&A. So I'll take these from
Sorry, I was on mute there, Adam. Just wanted to say thanks so much for that. There was a lot of great insights there. I know a lot of people will take a lot away from your talk. So yeah, just to get on questions, just to remind everyone to continue asking questions throughout, and just type in your name after the question so we can see who's asking. So for the first question, we'll go with Johan says, I have not done AI testing before, but would like to experiment in my own time. Where would you recommend to start?
Ooh, good question. I think there's a number of other, as well as me, there are other testing experts who've done some similar sort of presentations that are on YouTube and things like that. That's probably a good way to start to build your knowledge. You can start to, you can try learning a bit about data science. So there's a great website called Kaggle that has all sorts of interesting data science problems on there. I'll tweet that URL as well. And that's a good place to start to go and start to think about some of the quality problems I've talked about and how would they apply to the problems on that website. And just that thought experiment is probably a good way to start.
Great, thank you very much, Adam. So Brian McRoberts asks, you talk about bias. How do you make sure the testing does not have bias as well?
Fantastic question, Brian. That's something you have to try really hard to do. I guess one of the key areas is to involve people from different disciplines, ethicists, philosophers, statisticians, in your testing. And I think that applies to development as well. Bring people from different backgrounds and users and other stakeholders into your testing process to look at what you're doing and how you do it.
Great. I hope that answers your question, Brian. So another question I have here, are there any European ethic organizations for dev and test that we should look for guidance?
There's a lot of ethics organizations looking at these problems, and some of them are starting to get down to the technical what should we do level. I think as well as the standardization initiatives in the UK, you've got the Centre for Data Ethics and the Ada Lovelace Institute. And in the rest of Europe, there's also many other examples of that. In the US, there's a company called For Humanity, which is looking at verifiable tests that can demonstrate that AI is of specific qualities. And they're currently looking at contact tracing as well in a coronavirus context. So this is really it is a developing space. There's lots of organizations, but in terms of getting actionable lists of stuff to do, there's not that much out there yet.
Great, thanks, Adam. Just a reminder to everyone that this talk will be recorded and will be live on EuroSTARHuddle.com, so you can watch back and catch up on any of the questions as well and the talk throughout. So another question here is from Amisha Mittal. How AI is generating test data? Can you please provide a few more examples?
Sure. So I gave one example where there's a generative adversarial network that generates a face. In the example of synthetic data, the way it works is you take a production data set, let's say banking transaction data that you can't use in your test environment, but you want to replicate the shape of that data in your test environment to make sure that your test data is realistic. So there's ways of using machine learning to put that production data in and get essentially depersonalized data out the other end. But the difference to traditional masking and depersonalization techniques is it retains all the same statistical properties. So it has all the different edge cases in there, unlike where you just mask data and throw a load of X's in there or unrealistic values.
Great, thanks, Adam. We have a few more questions coming in now, so keep them coming, guys. Let's see. So we have a question here that says, what's the future? How will the role of the QA engineer change in 3 or 5 years' time? And that's from Bart.
So I think QA engineers will be part of AI auditing processes. There's another question as well about whether we're moving towards certification, which I think is very much related. I think in terms of AI systems being certified, yes, I think probably in 3 to 5 years, AI systems will be certified. And that's going to be based on the international standards that are developed and any regulations that are in place. I think they'll start being certified first as part of public sector procurement processes. And in order to do that certification, testers and other types of discipline will need to be involved in order to really come up with whether an individual system should be certified. I think in terms of if the question is around testers being certified, I think there's a lot of debate about whether testers should be certified and whether certifications have value. I'm personally of the view that you do need some kind of education to deal with specialist problems, and you do need some kind of certification, particularly in this space.
That's great, Adam. That actually answers another question that someone has asked to say, do you see us moving towards certification? That kind of relates to that question as well. Let's see, another question. Did I ask this one? Could you please give any starting point to autonomous systems? And that's from Ilke.
So there's autonomous systems. So I guess if we mean a system that achieves its goals without intervention, then a lot of the AI techniques that I've talked about apply to that example as well. I think there's some really interesting aspects when you think about autonomous systems that operate in the real world. So if you're testing, like, say, I don't know, a vacuum cleaner that goes around and vacuums your house, there's all sorts of interesting tests you can do, putting objects in the way, changing the humidity, thinking about other environmental aspects. So the environment, the physical environment, can be a really interesting point with autonomous systems. And also, what if you have two autonomous systems and how they react with each other, like a multi-agent autonomous environment?
Great. Let's see, any more questions coming in. Just to point out as well that we released on the EuroSTARHuddle 2 new Agile ebooks. So we have the 3 pillars of Agile quality and testing by Bob Galen and the T-shaped tester by Eric van Daal. So if anyone wants to find out any more Agile resources, you can find them on the EuroSTARHuddle. Another question here. Rainer says, does it make sense to use AI to test an AI system?
I think 2 answers to that. Generally, it does make sense to use AI to test systems, but there are risks. Now, if there are AI components to that system, then it may still make sense. Using AI to test the AI components to that system is novel. I haven't seen any examples of that being done. And we have to remember, there's a lot of things that that AI can't do in testing, right? It can't talk to your stakeholders. It can't figure out pass and fail. It can't figure out the requirements for you. So it's an interesting question. I've not thought about that in detail. I think it's possible.
That's great. A good tough question is always welcome. I think that kind of the questions are kind of slowed down there now. So if anyone does have any last minute questions, you can enter now. But yeah, thanks so much, Adam, for all of your insights and all your questions. I think there was some really great conversation there and a lot of great takeaways for everyone. So yeah.
Thanks for having me.
Oh, we're delighted to have you. So just a final key point to everyone. So this, just as a reminder, EuroSTAR 2020 is going online this year, and you can find the program on EuroSTARconference.com. So be sure to check it out. And all of the webinars from this series will be available on the EuroSTARHuddle.com. So be sure to check out to find all the other webinars. And just a final point to make, for those who attended all of the sessions this week, you will see that we used 3 different platforms. So we're just currently in the process of testing out all the platforms. And if you have any feedback or would like to let us know which platform you preferred the most, please give us your feedback and send us an email to communications@eurostarconferences.com. So yeah, that's everything for today. Thank you so much for everybody for joining, and thanks again to Adam. And we look forward to seeing everyone at the next webinar. Thank you. Bye-bye.